Hello again. Today I am just going to do a quick tutorial, as quick as it can be, on organizing your data. The past few days you've been collecting data and you created some sort of chart to catch whatever data you have. And I just want to use again our example of when we ran an experiment in our class for when students stood at the announcements. Was it because of the bell, or was it because, and what we found out was more people stood when our announcer said good morning Kiel High, right? So what I've done is I've started with my data, and over here I have my two pieces of data that I collected. We remember if we ran this for 2 days, which I have to tell you is not enough, but it gets us started. So my two pieces of data on day 1 was we had 1 out of 8 classes that stood when the bell rang. And on day 2, we had 100% of our classes stand when the announcer said good morning Kiel High. So we collected some data that said the percentage of students that stood when we spoke good morning Kiel High School. I am going to, per the discussion with the math department, I'm going to change one of my pieces of data from 12.5 to 10 because it just kind of goes with the rest of my numbers. I had to go in because I had only run my data for 2 days and randomly select some data. So there are some math charts that can do that. And so now I have 20 pieces of data. So for example, if I were to run this for 20 days, random selection says that this is what my data would look like. So I took that data, all 20 days of it, and put it into a and put it into a chart. And all I did was, as you can see at the bottom, it's 1 through 20 days, and it just tells you where my data fell for each day, 10, 100, and so on, okay? I took that information and I calculated a mean. And if you're wondering where I am in the textbook, you can find mean on page 486. And a mean is basically the average. I took all of my data, added it together, and divided by 20, which ended up with 56.5. All right? If you also look, I calculated a median. And this is kind of nice. It resists what we call outliers. Last year, a student was looking at the amount of sleep people had, and most of their data was between the 6-hour and 8-hour range. So that would be nice if that was all of their data. They could easily collect an average because it would be somewhere between 6 and 8 hours. However, an outlier was there was one student who that night had slept 13 hours. That is going to mess up your average. And so in that case, a median is really nice. All I did was I took my data from over here, transferred it into a nice line in order, and I counted to the middle. So over this way and over this way, and my median is 60, which is kind of nice and very close to my average. So that kind of tells me that my data is very nicely distributed. So then, in our textbook, what am I going to do with my data? I could make a bar graph. I could take this information, just chart it and show you. That's not really incredibly helpful. And so there are some solutions that we can use, or some different ways we can organize our data so it's going to make some sense. I took my median because that works the best for my data, to kind of see what I have. And all I did was I created a frequency chart. Let me make that a little bit bigger. It's a little hard to read. Oops, that's a little too big. Here we go. So on the bottom here, I just took all of the times 0 popped up, 10 popped up, 20 popped up, all the way to 100% popped up. And every time that my numbers came up, how many times they came up frequently, I put it here. So one time in all my data, 0 came up. One time, 10 popped up. 2 times, 20 popped up. 3 times, 30 popped up, and so on. Okay? You can find a frequency histogram, bar graph, and it explains all of that on page 485 in our textbook. I left that right here. And then what we can do with this is we can start looking at standard deviation from this. Standard deviation is on page 487. And standard deviation really is just like how scores differ from your mean or your average. Okay, how far away from the mean are they? And when it's a really high standard deviation score, and here's my note for that, there's a lot more variability among your scores. There is on page 488 of your textbook, and I don't have it written here, a standard deviation equation. So if you want to go to page 488, and basically what we can do with that, and I just kind of gave you my data to help you figure out how you would put in information into the formula, but you have the sum, which is a collection of all of your data added together. Your x is whichever data you are focusing in on. So mine, I just took the first one being 10 and I put it into my x chart. The m is your mean or your average, and then the n is your total sample. And if you want a total sample for a population as a whole, or society as a whole, you put in 20. If you're looking for your representative sample, you put in 20 minus 1, or n would stand for 19. And all you would do is you can figure out how far away your scores are from your mean. And so that is another really unique way and a really interesting way to try to analyze your data. Another thing you can do with this data, and I found from my data that I don't really have enough data, okay? And the real reason I know I don't have enough data is because on page 489, so I'll write that down for you quick. Page 489, there are curves. And curves really should have a normal distribution. Hopefully this is going to work. But when you have a normal distribution, my curve should look something like this. Oops. Let me erase a little bit because that's screwed up. Something like this. Okay? My curve does not look like that. I'm going to use my highlighter. You can kind of see that mine goes like this. And it almost stays really stagnant and really in line. And that is not normal. And so what that tells me is 20 data points on this experiment that we ran is not enough. Okay? You can sometimes have skewed data. You can have skewed curve, and those are on page 490. And that's basically just telling you that you're really more towards this side or this side of your data. But actually, if you have a true curve and you have true data, it should normalize out. So what I put on down here for a little note was a theoretic curve should be this red line. And that's theoretic. We know it's not perfect. Okay? So I think that should give you a good idea of how to organize your data. It gives you some ideas of how to use your appendix at the back of the textbook. Hopefully this has been helpful for you. Try it out. It's just a way to evaluate your experiment to see whether or not your data is really supporting or not supporting your experiment. I hope the rest of your experiments go really well. Thank you so much.